Hello and welcome to your stats video. So this is just a lot of practice problems involving kind of two proportion hypothesis tests and two proportion confidence intervals. So in 2000, the United Nations claimed that there was a higher rate of illiteracy in men than in women in the country of Qatar. A humanitarian organization went to Qatar to conduct a random sample. The results revealed that 45 out of 234 men and 42 out of 251 women were classified as illiterate on the same measurement test. Do these results indicate that the UN findings were correct? All right. So again, our null for these is always that there's no difference, so that the proportion for men would be the same as the proportion for women, right? In this case, the problem says we're expecting a higher rate of illiteracy. So we're expecting the proportion of men to be greater than the proportion of women who are illiterate. And our alpha, we're going to still keep at the 0.05%. All right, so if we go over to our calculator, we're going to go to stat tests 2 prop z test. And then it's going to ask us for a whole bunch of information. All right, x1 is the proportion of men. So our men that were illiterate, 45 out of a total of 234. And then x2 is for the women, and that was 42 out of 251. And in this case, we're testing that we think that we are larger than P2. Because again, the order that I type them in, I put the men in first, the women in second. So I'm testing that we are greater than P2, right? Depending on the order in which you type them in, you might be picking a different thing here. But based on my order, that's what I got. So this is showing you the two percentages. So about 19% of men were illiterate, 16% of women were illiterate. Is that gap big enough that we're confident that it means something? Well, we ended up with a test statistic of 0.7164, and we ended up with a p-value of 0.2369. All right, that is above our alpha. So because our p-value is above our alpha of 5%, we fail to reject the null. All right, so this real world difference that we observed, 19% to 16.7%, was not large enough for us to confidently say that more men are illiterate than women. So we're just failing to reject the premise that the two of them are equal. All right. We had a 24% chance effectively of getting a result like this, assuming this is true. So we can't confidently say that it's not. Number 2, find a 95% confidence level for the difference in proportions of literacy in men and women. So if we're doing men minus women, what is the possible values that could result from comparing those two things? So again, we're going to go to stat tests. This time we're going to 2 prop z interval. So 2 prop z interval. And it's mostly asking for the same information. So it still needs to know x1, and those haven't changed. It still needs to know n1, x2, n2. Only this time it needs a confidence level, and the problem tells us that our confidence level is 0.95%. All right, so we get a value of negative 0.0435 to 0.0934. Or put another way, we are 95% confident the true difference again, men minus women, because it's important to specify which direction you did it in, is between, negative 4.35%, which would actually suggest that more women are illiterate than men, and 9.34%, which would suggest that men are significantly quite a bit more illiterate than women. All right. But negative would actually, in this case, suggest that women are more illiterate. Positive would mean that the men are more illiterate. And again, that's just because of the order in which we did our subtractions. All right, let's take a look at the next one. At a community hospital, the burn center is experimenting with a new plasma compress. A random sample of 316 patients with minor burns received the plasma compress. Of these, it was found that 259 had no scars after the treatment. A random sample of 419 received no compress. Of these, it was found that 94 had no visible scars after the treatment. Do these results suggest that there is any difference in the two treatments? All right, so notice that this doesn't say better or worse. It just says, is there a difference? And this is where you kind of have to sort of suspend your disbelief, because if you were setting up this experiment, you made this choice before you got the results. All right, so I know us looking at the results, it's like, all right, well, why wouldn't you just test that one is better than the other? Because you're making this decision prior to actually gathering the results, based on the background research that you've done. Maybe you don't have a clue whether it's going to be better or worse, so you're starting with a not equal situation. All right, but again, we're going to set up our null, and we're going to start with the proportion with plasma. We'll say plasma compress is the same as the proportion with no plasma compress. And the alternative is that the two are not equal. And again, it's because they're saying, is there any difference, that we're just using not equal to. Our alpha is going to be 0.05. And again, we're going to be doing the 2 prop Z test. All right, so we go to stat, we go to tests, 2 prop Z test. On the first one, it was 259 out of 316 had no visible scars. And on the other one, it was only 94 out of 419 that had no visible scars. And again, we're doing a not equal to in this situation. So X1 is 259, N1 is 316, X2 is 94, N2 is 409, and we're doing that P1 does not equal P2. All right. When we do that, you're going to see that we end up with a test score, or a test statistic, sorry, not test score, test statistic of 15.7548. And then be careful there, because our p-value is really, 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 really tiny. There's an e to the negative 56 there. So it's 55 a decimal, 55 zeros, and then 67. I am not writing 55 zeros, so I'm just going to write this as 0.67066 times 10 to the negative 56th. So basically, they're saying there's no way that these two are equivalent, which is what we would expect. If you look at the sample results, if you look what actually happened, with the first treatment, 81.96% had no scars. With the second treatment, 22.98% had no scars. So if you ask anybody, is there a difference between 81% and 82% and 23%, they're going to say, yeah, that's a huge difference. which is what this tiny, tiny p-value is reflecting. All right, there's no way you're getting a gap that big because of sampling variation if these two are equal. All right, it's just very, very low probability, which leads us to the conclusion that they're not equal. All right, so because our p-value is under our alpha of 5%, we reject the null and accept the alternative. All right, and then 4 is kind of extending this to a confidence interval. It says find a 95% confidence interval for the difference in proportions between the two treatments. Do the hypothesis test and the confidence interval reach the same conclusion. So again, we're going to be doing a 2 prop z interval. All right, it's going to be asking for the same information as before. So we're going to be using those same values that we used the first time. Only this time we're providing a confidence level of 95%. So let me bring that up. Stat tests, 2 prop z interval. All the numbers are already in there. Hit calculate, and I get a interval from 0.53097 to 0.64861. All right. So that's saying we are 95% confident. The true difference, and this is compress minus no compress, is between, let's say, 53.1% and 64.9%. Now, do the hypothesis test and the interval reach the same conclusion? Yes, they do, because we rejected the null and 0 is not in our interval. All right, so remember, 0 represents no difference. So if 0 had been in our interval, we would have said, all right, there's a possibility there's no difference. There's a possibility that these two things are equal. But 0 is nowhere close to our interval. So we're not accepting this premise that they're equal. So it does support this conclusion that they are different from one another. All right. Which on this one, again, the percentages are so different that it should have been pretty, I think most people just intuitively would have recognized that there was a big difference here. All right, one forest in Oregon has an infestation of spruce moths. In an effort to control the moth, one area has been regularly sprayed from airplanes. In this area, a random sample of 495 trees showed that 81 had been killed by moths. A second nearby area receives no treatment. In this area, a random sample of 518 trees showed that 92 had been killed by the moth. Do these data indicate that the proportion of spruce trees killed by the moth is different for these areas? Again, based on the language of this question, we're not saying better or worse. We're just saying different, which implies not equal to. Again, you might say, like, why? We have the results. Because you choose these things before you have the results. All right. It's just doing them in a classroom setting. We're kind of have to suspend the fact that we know this information and pretend that we're designing the experiment first and then collecting the data later. All right. So again, our null would be that the proportion with spray is equal to the proportion with nothing. Our alternative, based on the way this is written, is just that they are not equal to one another, and then our alpha is 0.05. We're going to, again, be doing the 2-prop Z tests, and that's going to want to know our x1, our n1, our x2, our n2, and then for us, we're going to be doing a P1 is not equal to P2, or PS is not equal to PN. All right, but let's bring it up on the calculator. Stat tests. 2-prop. Where am I? 2-prop Z test. And this time we're doing 81 out of 495 and 92 out of 518. So there are our two sample results. All right, one was 16.36%, one was 17.76%. Is this gap large enough that it's significant, or can we not rule out the possibility that the spray didn't do anything? All right, well, let's look at our test statistic and our p-value. So our test statistic was negative 0.5906. And that test statistic leads to a p-value of 0.5549. 0.5549. All right. So that's basically saying there was a 55% chance of getting the result that we got, assuming this is true and based on our sample sizes. So that's a pretty high probability. So because our p-value is above our alpha of 5%, we fail to reject the null. All right, there's not enough evidence to say that the spraying actually did anything, because we had a very high likelihood of seeing this gap that we saw just because of sampling variation. All right, this gap isn't so large that we have to believe the spraying did something. It's close enough that it could have just been, the way it broke out this time. All right, 6, find a 95% confidence interval and then do the hypothesis test in the confidence interval, reach the same conclusion. All right, so before we do this, let's just say what we should expect to see. All right, in this problem, because we failed to reject the null, we couldn't eliminate this as a possibility, which suggests 0 should be inside of our interval. All right, now we're going to test it and see if we actually end up with 0 inside of our interval. But that's what we're expecting to see. We're expecting to see 0 land inside of our interval because we failed to reject the null. All right, x1, n1, x2, n2, and our confidence level is going to be 95%. Now, I didn't actually fill this in up here. 81, 495, 92, 518, and then I'm using the same numbers down here. 81, 495, 92, and 518. All right. So if I bring that over to the calculator, stat tests, 2-prop Z interval, the numbers are already in there for me because I just did the hypothesis test. I'm going to get an interval between negative 0.0603 and positive 0.03235. So just like we expected, 0 is inside of our interval, which is supporting the conclusion we reached with our hypothesis test. So we are 95% confident. The true difference, spray minus no spray, is between negative 6.03%, meaning the spray was actually worse, and positive 3.235%, meaning the spray, did have a slight improvement. And does the interval support the hypothesis test? Yes, they reach the same conclusion. Because 0 is in our interval. All right, and again, a difference of 0 implies no difference between spray and no spray. Because when you're subtracting those two proportions, you're getting 0, which means they're the same, which means there's not really a difference that you're observing. All right, last one here. Researchers conduct a study to test the claim of less side effects from a new allergy medication. A random sample of 160 subjects was selected for the study. The new improved brand 1 medication was given to 80 subjects, and the current brand C medication was given to the other 80 subjects. 14 of 80 of brand I, it's probably I, not 1, reported drowsiness. 22 of 80 with brand C reported drowsiness. Test an appropriate hypothesis and state your conclusion. All right, so we're testing that the new drug, so brand I, has less side effects. So we're expecting a lower percentage than what we find in brand C, which is the traditional one. Whoops. Our null is that we expect no difference. Our null is always that there's no difference. Sorry about that. Our alternative is that we're expecting PI to be less than PC. And again, our alpha is going to be at 5%. All right. Again, we're using our one prop Z test. It's going to be asking for X1 and N1, X2 and N2, which in this one is 1480 and 2280. And in this case, we're expecting P1 to be less than P2. All right, so stat tests, 2 prop Z test. We've got 14 and 80. We've got 22 and 80. And again, we're expecting P1 to be less than P2 because we're testing for fewer side effects. All right, so there's the observed values, 17.5%, 27.5%. Is that 10% gap big enough? Well, it gives us a test statistic of negative 1.51, and it gives us a p-value of 0.0649. All right, so it's close to our threshold. All right, but based on our sample size of 80 subjects in each group, that gap was not big enough to definitively say there is a difference between the two medications. All right, because it's above our alpha. So because our p-value is above our alpha of 5%, we fail to reject the null. All right, and then the last one here says, find the 95% confidence interval for the difference between these two treatments. In this situation, is the confidence interval providing the same information as the hypothesis test? Why or why not? So we'll answer that first. No, it is not. Because the hypothesis test is one-tailed. They only match up it's a two-tailed test. All right. Now, with that out of the way, let's actually get our interval. And again, this time we're going to be doing, brand I minus brand C. We're going to use the 2-prop Z interval. And we're going to use pretty much the same information. 14, 80, 22, 80, and then a confidence level of 95%. All right. So stat tests, 2-prop Z interval, 1480, 2280. Whoops, stat tests. Hit enter one too many times. All right, so we get an interval of negative 0.2285 to positive 0.02848. So yes, our interval contains 0. So you might be like, wait, it is matching up. But again, you can't rely on that. All right, we can only match them up when you're doing a, not equal to or a two-tailed test, not the one-tailed test. So in this one, all we can really say is we are 95% confident. The true difference of brand I minus brand C is between negative 22.85% and positive 2.848%. Right. So again, a negative value there would mean that brand C had more side effects. And then the positive, this little positive part on the other side would be that brand I actually had more side effects. All right. But that's kind of how you work through these problems. All right. You've got to set it up. You've got to be able to identify the null and the alternative. You've got to be able to know where to go to kind of enter this information. And then you have to know how to interpret the values that are coming out of that. All right. So I hope this was helpful. If you've got any questions, let me know. Otherwise, have a great day.